All right, so for radical equations, so far we've looked at how to graph them. We've done it on the calculator. We've also done some by hand. We looked at how to describe transformations. That was the ABCD chart. The last thing we're going to look at is how to solve equations with radicals. So the goal when you are solving an equation that has a radical in it is to isolate the radical on one side. Okay? That means to get the radical alone. Here is an example of an equation that has the radical alone. The square root of x minus 3 is on the left. There's nothing else outside it. Here's an example where the radical is not alone. Now there's a times 5 on the same side. First thing we have to do is get rid of this times 5. Okay? But we're going to start out with ones where it's already by itself. Okay? So we make sure we get it by itself, and then we want to cancel out the radical. So if we were dealing with a square root, what is the opposite of taking a square root? Squaring, yes. So we would raise each side to the power of the index. When you're doing a square root, the index is a 2. So you square each side. If we were doing a cube root, the index is a what? A 3. So we would cube to get rid of a cube root. Okay? We always want to make sure we check our answer because it is possible that we get one that doesn't work. So always make sure we check our solution. All right, and I'm just going to make up some different questions. All right, so we'll start. Bless you, Bless you. Okay. Start with the easiest type, and then we'll build up. Square root of x plus 3 equals 12. Okay, so first question, is the radical isolated on one side?
Yes.
Yes, it is. So then we're going to raise each side to the power of the index. There's no index written there. So the index is a 2, which means we're going to raise each side to the second power. So square. Square. What happens when you square and square root?
Cancel out.
That cancels out. What does that leave you with on the left? X plus 3. And what does that leave you with on the right?
144.
Yeah, you're left with 12 squared, which is 144. And that gets us to our last step. What would we do on both sides to get x by itself?
Subtract 3.
Subtract 3. Okay, that's gone. And 144 minus 3? 141. Okay, let's check it, make sure it works. If you plug it back in, what's 141 plus 3? 144. And what's the square root of 144?
12.
12. Yep, works fine. Any questions on the first one? All right, let's try the next one. 2. Let's do 3 times the square root of x plus 6 equals 21. Okay, so first step. Is the square root by itself?
No.
No. You need this box to be alone on one side. Why isn't that box by itself?
Because there's a times
There's a times 3.
Would you divide it by 3? Divide both sides.
So we're going to divide both sides by 3. Yep. So that's divided by 3 is going to cancel the times 3. And now we have that.
And now you square both sides.
Now we can square both sides because we move the number to the other side. What happens when you square and square root? That cancels. And what's 7 to the second power?
49.
49. And my last step?
Subtract 6.
And 49 minus 6?
40.
43. So let's check it and see if it works. What's 43 plus 6?
49.
49. What's the square root of 49?
7.
7. What's 7 times 3? 21. Yeah. So that one works. A little bit, well, not that much harder, but it definitely has an extra step than the last one. Okay. Any question on that one? All right. Let's try this one. Let's try 5 times 3 square roots of x plus 2 equals, actually, you know what, let's make that a minus. And now on the other side, let's put 11.
Should we combine the like terms first and then subtract it? Like 5 minus, like 2 minus 11, or like that?
No, these can't be combined because you always have to do multiplication before you do
Oh.
subtraction. You have to follow PEMDAS. So no, there's no like terms we can combine. So we just have to get this by itself. For now, you can basically think of that, think of it like this.
Would you subtract 5 and add 3?
Don't even worry what's in that box. Just get that box by itself. What would be your first step?
Divide by 3.
Subtract 5.
So you could subtract 5 from both sides. That's gone. And now you have negative 3. I need to know what was in that box. Square root x plus 2 equals 11 minus 5 is going to give me 6.
And then you add 3.
Divide.
Divide by negative.
Negative 3.
And divide by negative
Wait,
3.
why are we dividing?
Because it's multiplied to the
Oh, I didn't
box.
realize.
Yep. So that negative 3, because it's just in front, is a times. So to get rid of times, we use divide. So that's gone. And what does that leave me with on the left?
Negative 2. Oh, no. X plus.
Square root of x plus 2. And how about on the right?
Negative 2.
Negative 2. Okay. Now what?
So you square them.
Square both sides. And what we get? What happens on the left when we square both sides? Cancels. And on the right?
4.
Get 4. And the last step to get x by itself. Subtract 2. And that gives me x equals
2.
2. All right, let's plug it back in and check it. So if we plug in 2, remember this is what we had originally in red. Right there. Plug in 2. What's 2 plus 2?
4.
4. What's the square root of 4?
2.
2. So now we've got 5 minus 3 times 2. What's 3 times 2?
6.
6.
What's 5 minus 6?
Negative.
Negative
So it
1.
doesn't work.
It didn't work. Right? It's not that we did anything wrong. It's just this type of problem probably has no solution. It's probably a no solution. So that's why you need to check your answer. Right? Any questions why 2 doesn't work?
So if this is on a test, would we like just write no solution?
Yeah, you'd have to cross this out and write no solution. If you wrote 2 as the solution, I might give you half credit because you at least knew how to try to solve it, but you didn't check it. Yeah. Any other questions why 2 doesn't work? Yeah.
Wait, would that be extraneous?
Yeah, you could call that extraneous. Yeah. Yep, it doesn't work. Anyone need me to show you again why it doesn't work? Okay. So that would be extraneous. any questions on solving those types of equations, either the basic ones or the ones that started getting a little harder and had no solution?
What
Yeah.
happens if there's two roots?
If there are two, well, we're only going to be dealing with square roots, so you wouldn't, what do you mean two?
Like two things and then x, like x plus 2. So
Oh, like if you had, I think I know what you mean, something like that.
yeah.
We're not going to have one with two roots.
Okay.
That's a little bit harder than the ones that I showed. Yeah. The kind you're going to see on the test are going to be more like that, or that. Yep. Okay. Any other questions on that? Okay, so let me put up this. Pause that. Okay, so the first part, the homework tonight is on 255. It's 20 to 24 and 31. It's all questions like we just did. You'd probably be able to do each question in under a minute or two. All right, so Chapter 5, we're going to look at another type of function. Which function were we just looking at in Chapter 4? Radicals. Yeah, we're looking at radicals. So Chapter 5, we're going to do some of the same things we did in Chapter 4, but we're going to look at what are called exponentials. Okay, just a different kind of function. Okay, one thing we are going to do is transformations. And I'm going to put that ABCD chart up again, but it's going to be the exact same chart we did yesterday. So hopefully it comes a little easier today. We'll see. All right, first, I just want to look at those two things. The first one says x to the second, and the second one says 2 to the x. In each case, there's a base and there's an exponent. In this one that I just put a box around, what is the base? X. And what's the exponent?
2.
2. How about in the green box? What's the base?
2.
2. And what's the exponent?
X.
X. Having a letter as an exponent is one of the things you need to have for it to be called exponential. Having a letter in the exponent is one of them. If I were to graph both of them, which one of these do you think curves up faster? X squared or 2 to the x?
2 to the x.
Yeah, 2 to the x curves up a lot faster. For example, let x be, you could pick a number, like let x be 10. In this one, if x is 10, what's 10 to the second power? 100. Now, let x be 10 over here, and see what you get. 2 to the 10th power, 1024. And the bigger you start making x, the bigger and bigger the difference is going to be. Okay? Anything with a variable in the exponent is going to go up a lot faster than something that doesn't. Okay, so any question on the difference between these two? So up until now, the kind of things that we've studied, like in chapters 3 and 2 when we did those, we studied polynomials. So what's in green there, that's what we've done before, where the base was the variable, like x cubed. The base was the variable, and the exponent was a number. What we're doing in this section is we're switching it. Now we're going to do this. This is what makes something exponential. I told you one of the things that it needed to have was a letter in the exponent. The other thing it needs to have is a base that's positive, but it can't be the number 1. That's what makes something exponential. Variable in the exponent and a base that is a positive number other than 1. Somebody give me a positive number besides 1. 7 to the x. That is exponential.
So as long as the bottom number is not 1,
Right, as long as this number is not 1,
and that's an x,
and that has to be a letter. Could be
or
other,
any letter ever.
could be something other than an x. Yep. How about this?
No.
No.
No, that's not exponential. You can't have a 1. It has to be a number besides 1, and it has to be positive. So this also is not exponential. You might say, well, wait, it has a variable that's an exponent, but the base is not positive. It has to be positive. Yes?
What about those numbers that are like, it'd be like 2 to the x plus 1?
That would also be, yeah, you could have a number up there, x
Okay,
plus
so as long
1,
as there's a letter in it at all, it's,
in the exponent.
yes, in the exponent.
Yeah, if you
I
had a
didn't know,
plus.
because like that also had a not letter in it.
Yep, you could have a plus 1 up there, that's okay. Yep. But you gotta have a variable in the exponent, and you have to have a base that's positive and not 1. Right, let's graph an exponential and see what it looks like. I think the one we said was 7 to the x.
Yeah.
Right, let's graph it and see what it looks like. So you notice, let me do zoom 6. Once you get past the y-axis, what happens with the graph?
Goes up.
Yeah, it starts to curve up very quick. It curves up very quick. It's not vertical, right? It gets pretty steep, but it's never vertical. Let's look at that a little bit. Okay, when you look at that graph, how far to the left does it look like it's going?
Negative, or like
Infinity.
infinity.
Yes, it's going to keep going to the left forever. And as it continues curving that way, which direction is it heading in as you go to the right?
Well,
It's heading up, and it's also heading to the
Right.
to the right. Yeah, it's slowly to the right, but it is going to keep going up and to the right. So what do you think the domain is? How far left and how far right does that blue graph go?
infinite,
Infinitely right. and
negative
left.
infinity
Yeah, negative infinity.
to 1.
To infinity.
So it stops at 1. That's 1. That means it stops right there.
To negative infinity to infinity.
Negative infinity to infinity. Yep.
Can we
That's
try all real numbers?
that's the domain of that. Yeah, that does mean all real numbers. Every exponential function will go left and right forever. It doesn't matter what you put in for an exponential function. Let's do 2 to the x. 2 to the x is going to have the same look as 7 to the x. The only difference is 2 to the x curves up a little bit slower, but it's still going to go left and right forever. How about the range there? Either the blue one or the red one, they have the same range. Do they go up forever?
Yes.
Yes. Do they go down forever?
No.
No. It looks like they're kind of leveling out and getting close to something.
To 0.
Yeah, they're getting very, very close to 0. If you plug in negative 10, you get 0.0009. Pretty small. If you plug in negative 20, now you get 0.000009. But is that 0?
No.
No, it's very, very small. So as this graph curves down to the left, it's getting close to 0, but it is never reaching. Yep. Okay, and just remember, when you're writing an exponential function, we just said that on the other page, a is a positive real number, but it can't be 1. Okay. The reason it can't be 1 is because watch what happens if you put in 1 to the x. Remember, these exponential functions have to curve. Does 1 to the x curve?
No.
No. That's because if you keep raising 1 to a power, it never changes. It just stays the same. Okay. How about 3 to the x? Would that be exponential?
Yes.
Yeah. So that would curve up a little bit quicker than 2 to the x. So that's 3 to the x. 2 to the x is probably going to be just to the right of it, like right out there. All right, so let's look at some other examples. These are all exponential functions. Okay, just different examples. What makes each one of them exponential?
It has a base
2 things.
that's not 1.
They all have a base that's positive and not 1. The base is 10, the base is 4. Even the base here, this is irrational. It's 3.14 and it just keeps going. That's fine. It's a positive number and it's not 1. Okay, and what else do they all have?
A variable.
A variable where?
The exponent.
In the exponent. And just to do something like that, you can definitely put like pluses and minuses in the
Does the
exponent.
variable have to match up with the one in parentheses?
Yeah,
Alright.
because whatever you write here, this means, like when you write something like that, that means what you are about to see is the letter X. It's kind of just foreshadowing what letter is going to come next. These are all things that are not exponential. Why is this first one not exponential?
Because it's a variable on the bottom and a number at the top.
Right, that's a polynomial. That's like x cubed. Right? You're supposed to have a variable in the exponent. So that's not exponential. G of x, instead of dividing by 2, you could think of it as 1/2. That's also not exponential. Your exponent's a 4. Your exponent's supposed to be 11. Okay. And this one, the last one that says y equals, that's a combination of a radical, which we talked about in the last section, and rational. That's not exponential. Okay. So is there any question on why the top ones are exponential and the bottom ones are not? And those are the old examples. Those are just examples I made up. While we look at that, does anyone have an idea what a -2 is going to do to that graph?
It's going to go down.
It's going to be some kind of shift. We're going to talk about what it is, but it's easy going to shift 2 units in a certain direction. Yep. But we'll talk about that in a little bit. We've kind of already looked at those 2 graphs. Okay. Does anyone need me to draw? Actually, I think I still have them drawn right there. The blue one is 2 to the x, and the red one was 3 to the x. Right? And what we notice is that the blue one curves up faster than the red one. What point does it look like they both go through?
0.
What coordinate?
1,
So how would you write that as a coordinate?
1, 0. 0, 1.
0, 1.
Yeah.
Yep, they both go through the point 0, 1. Okay. In fact, it doesn't matter how many of these you draw. If you don't put any pluses or minuses up in the exponent, and you just keep graphing ones like that, they're all going to go through the point 0, 1.
So
Yep.
it's the blue first.
All right. Now, one thing that can make looking at these kind of functions a little hard is if you have a negative in the exponent. Okay? We don't want to have negatives in the exponent. So does anybody remember what a to the -1 power really means?
A times -1.
No, the negative doesn't have anything to do with making a number positive or negative. I'll tell you that.
Then I have no idea.
What does a negative in an exponent do? So let's try an example. Here's 2 to the -1.
It needs to be decimal.
Here's 2 to the negative 2.
Oh, it's like a fraction.
Shrinking it.
So like 2 to the negative 1 would be 1/2.
2 to the negative 1 is 1/2, yes. How about 2 to the negative 2? It would be 1/4. Yep, 0.25. So when you have a negative as an exponent, what that does is it causes your fraction to flip. So let's say you had 2 to the negative 4. How would you write that as a fraction? 1 over
8.
4,
Half.
2.
Yes.
I don't understand.
Well, what's 2 to the 4th?
I don't understand what's a fraction.
16.
Should be 1/16?
So 2 to the negative 4th is 1/16.
Go me.
That's
What's that?
complicated.
Nothing.
Does that make sense?
Yeah.
How about what's 3 squared?
9.
9.
9. So what's 3 to the negative 2?
1.
9.
1 9.
So it's the opposite. of
Yes.
the-
Flipped. Yeah.
The opposite.
Yeah.
Do we need to know this? Because that make my brain hurt.
All right, let's try one more.
I think we do need to know this.
How about what's 4 squared?
16.
That's a
16.
So 4 to the negatives, it would be 1/16.
1/16.
So even if it wasn't 2, what if it was like 4 to the negative like 5th?
So, well, if it was 4 to the 5th, I'd have to figure out what that is first.
And then you would just put a 1 under the
And then I
top
would
of it?
flip it, yeah.
Okay.
Yeah, basically the negative, you just put a 1 on top.
So
Yeah.
4 to the 5th is 1,024.
Can I?
So the negative fifth would be 1 over 1,024.
You're on roll, Cassidy.
Look
Yep.
at you.
So what a negative exponent does is it causes the answer to flip.
I hope that's an error.
So now, what would a to the negative 1 be?
Is that going to be on the test? 1.
1A.
Really?
Oh, no.
1 over A.
1 over
Yeah, it's the same thing we just did.
1 over A.
Yes.
But is there going to be numbers on
Oh my
this?
god.
There'll be a combination of numbers and
Okay, because I'm
letters.
not going to know. Like,
Yeah, I'll just take the 25 now.
just
Well, if you try, you might do better. If not, then you won't.
Well, is that an option? Can I just take a 25?
You always have options, but I would encourage you to
You can
try.
just take a 0 if you want.
Well, I think that's going to be your best grade.
Yeah, I think that's a safe bet.
So, a to the negative 1 means 1 over a. Anything to the negative power causes whatever you have to flip.
Hi.
Right? Causes it to flip. All right. So now, let's look at this.
Oh, God.
Let's say we had
Let's say no.
2 to the negative x.
Oh.
All right?
See, like, there's no number there.
X
So-
over 2.
I have some
Look at-
problems.
What?
Look at what happened when we changed this.
Oh, would it be
Did
2
you-
over x? I
1
mean, 2
over
under
2x.
x.
So start with this. What's this called?
A.
2.
Well, what's that called?
Negative 1.
That's
Exponent.
Negative X.
exponent.
That's your exponent,
Base.
and that's your base.
Yay, I'm a genius.
When we rewrote it, what happened to the base?
It went on the bottom.
Yeah, it flipped.
So it's going to be negative X.
Here's your base.
It's going to be 1 over 2.
It's gonna
Oh,
be
not.
the
There's no
base.
1. It has to be x.
Wait, but where'd the 1 come from?
Why is it not x?
X equals
Oh
1.
my.
What do you mean where's
How?
the
But x
one?
can equal anything.
There's only one X.
Well, okay, write your base as a fraction. How do you write 2 as a fraction?
2 over 1.
Okay. So now, when you,
But there's
when,
an X.
when you rewrite it,
Same thing.
take your base and flip it. That's what we did
So it has
there.
nothing to do with the number and the exponent?
So what do you get when you flip your base?
1 over 2.
1 over 2.
1 over 2.
But what if the exponent can be anything and I thought that x...
And now,
I don't think he was done writing the original.
what happens once you flip that? What happened to this negative exponent when we rewrote
It
it?
became a positive 1.
It became a
So
positive.
would it be 1/2 and then a positive X at the top?
Yeah, I'm confused.
Yep. So let's try another one. Let's say you had 3 to the negative x. And if you want to think of it as a fraction,
Would be
1
1/3
over
X.
3 in parentheses.
But what if
X.
the x was like a 4?
when we're graphing, no, it has to be a variable.
Okay.
because to be an exponential function, you need a variable in the
Great.
exponent.
Alright,
We're your smartest class.
I'm moving to my.
Smarter.
I'm gonna be smart.
Alright.
I just need
I'm looking
more time to
smart.
understand.
I don't need math.
Does
Does
it
it
Any-
need the parentheses?
What?
Does it need the parentheses?
No, you can write it without parentheses.
Okay.
I just put it to emphasize that
I
it's
didn't
a
know if it
fraction.
mattered.
So what if we had, let's try this one.
You're just into this one. Great house.
4 to the negative x. We don't want to have that negative exponent. So the first thing we do is take the 4 and do what?
We turn it into
Flip it.
Flip it. 1/4.
And you flip
And
it.
then parentheses x.
That's how you get rid of a negative exponent. You
This is gonna be a great video.
take the base, flip it, and then the exponent turns into
I
a
got
positive.
this. I'll never forget this.
Smartest class.
Back
Now,
up the stage.
let me, okay guys, let me graph it and show you that those two things look exactly the same. Take 4, raise it to the negative x.
And why can't we have negatives again?
It's going to make it more confusing to analyze. The negative is going to make it more complicated. You'll see why.
More complicated than this.
So this is like a convenience thing?
Yes. So look at what I'm graphing on the left is 4 to the negative x.
Is there a way to type fractions into the calculator? Because like, what if I don't know the decimal conversion?
You should know this now. Like.
I know.
And then look at, okay guys, look at the one that's on the right. It's exactly the same thing.
Oh, Jesus.
Okay?
So why do we have to do that?
You'll see why.
Okay.
Because if you have a negative exponent here,
Yeah.
it's going to confuse you about this number.
Then they should just never put negative exponents in it ever.
My favorite.
All right, so now let's look at that. I want to graph each one of those.
I know how to graph.
That's the same thing.
Okay, when we graph exponentials, there's two kinds of exponentials. You might have heard exponential growth is one that goes up, and then there's exponential decay.
I learned that from here.
Okay, when you look at those, you might look at them quickly and say they both have a base of 2.
Yes.
The problem is the second one has a negative. Okay? When there's a negative, we can't work with it.
Doesn't mean it goes down.
Right, we have to fix it so there's no negative.
So
How-
would it be the 1/2 parentheses x?
Yes.
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 We
Genius.
did so good.
So what that really means here is because that's a 1/2, when
So
we
it's
draw
half
it,
two
what do you think's going to happen?
It's
Yeah.
gonna go
Same
down.
thing, but it's
Yeah.
backwards.
by 1/2.
So let's put in 2 to the x. Let's see how that one looks. So that one's going to curve up as you go to the right. That's the top one.
Then would you do 1/2? Would you do the 1/2 x one, or would you do 2 negative?
I would use the 1/2 one.
Okay.
What do you think's going to happen when we put in that one?
It's gonna go down.
It's going to go down. And the reason it's going down is because this number is less
Is that how you
than
type
1.
in fractions?
That's how I would type in the fraction.
Okay. Can I do that with any fraction?
Yeah.
Yes.
Yeah.
Okay.
Okay, so watch the red one.
It just flips. It literally just flips.
Yes.
It's so pretty.
I love symmetricalness.
Colors.
So now let's look at each of those graphs and then describe what's happening. Okay, I want to know the domain
Oh, I don't like that.
and the range.
No.
Okay, so start by looking at the blue one.
0.
This is the blue one, and g of x is the red one. Okay. What's the domain of the blue one? Yeah.
Negative infinity to infinity.
Right. Every exponential function has a domain of negative infinity to infinity. It doesn't matter if it's a growth or a decay. They all go negative infinity to infinity.
Okay.
So what's the domain of the red one?
Negative infinity to
It's
infinity.
the same thing.
Doesn't matter which one's first or second?
It has to be negative
Okay,
infinity
because that's
first.
slower.
Yes.
Okay.
When you write an interval, it's always low,
Got it.
comma, high. Now the range. Look at the blue one. What's the lowest that it looks like the blue one goes?
Almost 0.
0.
Almost 0. Does it reach it?
No.
No.
And then would it be infinity?
What's
No, it's 0.
then
but
what
you don't
symbol?
include it.
We don't include it.
So it's the parentheses.
It's the parenthesis.
And then you go up to infinity.
And we
And
go
you
up to
wouldn't-
infinity.
And you would.
And you
No,
don't
you-
include it because it's not like a number.
Because you can't include it.
And then would the
Wait,
other
what?
one be?
Would the other one
It would
be
just be
0,
on the
negative
opposite.
infinity?
So the red one goes down forever?
No, it goes up.
No,
It
that's
goes
me.
almost to 0.
It goes
Would it just
almost
be
to 0.
infinity and then 0?
Infinity, 0.
No, because then.
Well, you gotta write the lowest it goes and then the highest it goes.
Oh, so same thing.
It's the same thing.
Okay. Is that because they're both the 2s? Or would they always be the same? Is the
No.
range always the same?
Nope, they would be different if I did something like that.
Up.
Now that plus 6 is gonna move the graph up 6.
Okay.
So now the range of the blue one
Would
is
be
6
6.
to infinity, and the red one I kept the same.
Okay, I got it.
It's not pretty.
Okay, so no, the ranges don't always have to be the same. But the domains are always the same no matter what you do.
Anything ever?
For exponentials, yes.
Okay.
No matter how you take these two graphs and
if it
shift them,
has
move them, they always go left and right forever.
And if it has a negative, it's always going to be going down?
Yeah, because we're going to get rid of that negative and make
Yeah.
that into a
But
fraction.
you
Got it.
said domain's always the
I
same
don't know.
Right.
I feel like that.
Domain never changes.
for all of them.
Do you have
For all exponentials.
Yeah.
All right, so now, we looked at it specifically with a base of 2. Whether the base is a 2, a 3, a 4, the number here wouldn't make a difference.
Okay.
This chart would stay the same. So I want to write that idea down here. So a to the x would look something like the blue one. If it was a 3 to the x versus a 4 to the x, it might just be a little bit steeper blue one. But it's still going to look something like the blue one. When you have a fraction, it can be a 1 over 2, it can be a 1 over 3, 1 over 4, it could be any number. It's going to look something like the red one. So a to the x is always going to look something like the blue one.
Okay.
And a fraction, 1/2, 1/3, 1 over anything, is going to look like the red one. So now let's fill these out. As x goes to infinity, which way does that mean you're going? Left or right?
Right.
Which way is infinity?
Right.
To the right. So as you go to the right, f of x is another name for what letter?
X.
No, f of x is not x. F of x
Isn't that just
is,
like the label?
it's,
Why?
it's the name for, it's y. Yeah. F of x means y in
Okay.
algebra. So as x heads to the right, on the blue one, f of x is the blue one, what's happening to the y value as you head to the right on the blue one?
It's going to infinity.
It's going to infinity. Yep.
And beyond.
Now, how about as x heads to the left on the blue one?
It goes to 0.
It goes to 0. Yeah. And what happens to those two things when you look at the red one? They switch. So now, on the red one, as you head to the right, the y value is getting closer and closer to
0.
0. And as you head to the left,
It's going to infinity.
the y value is going to infinity. Right? So that summarizes basically what always happens in exponential functions. One side always goes to infinity. The other one always goes to a number. Does it have to be 0? No. Right?
So the bottom one is for the g of x, correct?
Yep. So like in this one, if you look
Oh,
at that
wait.
one, that blue one isn't going to 0. That blue one was going to 6. Okay, so you can shift it up and down. But I just want you to understand, one side goes to a number.
And they'll always be in this shape?
Yeah, they'll always have this basic shape.
Yeah, they're not going to like wiggle or anything?
No. Or you could flip
Yeah.
it. But they always have to
The
have
same shape.
that curved shape.
I got it.
You could curve the other way too.
Yep,
Yep. Always have to have that same basic shape.
got it.
So what's the difference then between whether the graph went like this
The negative exponent.
or it went like that?
The negative.
The negatives.
Okay, so we had that negative exponent. And let me go back to it.
If there was a minus 2, something like that, maybe.
And I want you to look at the bases. This one
They're the same.
versus that one.
They're
They're
half.
the same and then.
it's 1.5 less.
So what's the difference between these two bases?
It's just flipped.
One's a fraction, one's not.
Okay, so we got one's a fraction and one's not. So when you have a base that is a fraction, okay, a fraction between 0 and 1, your graph is going to decay.
So it doesn't matter if you have a negative exponent. Well, is the only way you can get that from a negative exponent?
Yes. So you would have gotten rid of the negative exponent to get that fraction. Yep.
What happens if it's a negative fraction?
No, you won't have that.
Okay.
Because remember, exponentials have to have a positive real number as the base. Cannot be a negative. So we don't talk about that. So what if I typed in 1/4 raised to the x? Is that going to be a graph that curves up
Down.
or goes down? Yes. That's going to go, you're going to see it come down as you go to the right. Okay, and the reason it's going down is because it's a fraction. Okay, that is called decay. Okay, when it goes down, it's decay. How about if I graph something like, let's get rid of that one, 5 to the x. Is that one going to curve up or down?
Up.
Right, that's going to curve up because this time the base is greater than 1. When the base is greater than 1, you get growth. When the base is between 0 and 1, you get decay. What if the base is exactly 1? It won't be. We said earlier it can never be 1.
Yeah.
And what if the base is negative? It won't be. It can't be negative. Okay, so growth looks like that. Decay looks like that. So any question on how you can look at something and tell whether it's growth or decay? How about, let me make up one more. Y equals 2/3 to the x. It's exponential. Would it be growth or decay?
That would be decay.
Decay.
Because-
2/3 is between 0 and 1. So that's decay.
If it was like, when you throw like an improper fraction in there, like, would an improper fraction be growth because it's more than 1?
Well, you could have something like that.
So
What's
that would be a growth because it's more than 1?
right? 5 divided by 2 is 2.5.
Okay.
That's greater than 1. Yep. So that's growth.
So like improper fraction would be growth?
Yeah, anything bigger, anything greater than 1
Okay.
is growth. Anything between 0 and 1 is decay. Any question on that? All right. So last thing we're going to do for today. All right, let's look at our ABCD chart. All right, so let's say we had a base, and let's do bx plus or minus a times c plus or minus d. So this is the same thing that we did yesterday with logs, when I had this.
But it's different.
What is all that?
Okay, so remember when we did this yesterday?
Yeah.
That's
yeah.
to be in an exponent?
Mm-hmm.
Oh.
So the difference today is we're not dealing with square roots. We're dealing with exponents. But it's still a bx and a plus a. It's still a times c in the front, and it's still a plus or minus d on the end. Let me
What's
just-
up with the base? Like what is?
the base can be any number that, it could be 1/3, it could be 2, it could be any number that's positive and not 1.
Is the plus or minus d supposed to be next to a?
Yeah, I'm just going to fix that. Plus or minus d on the end.
So there's no square root in this, right?
No, there's an exponent instead of a square root.
Okay.
Okay, but all of them are going to be the same.
So I'm assuming the exponents we're going to be seeing from now on are going to be like, we're going to have other things in them because it's all this?
Yep, you could have something like
I don't remember that.
Because like, I guess I'm
that.
Oh.
3 to the x plus 1, and I'm going to ask you what the plus 1 and the minus 5 are
We don't
going
have
to
to
be.
like graph that and say what they're like, what are we?
No, you're not going to have to graph it. You're just going to have to tell me
Okay, I can do that.
the transformations.
Ah.
Okay. So let's start with A. This is the part that's inside. Okay? This is like the part that was
That
under
means
the
it's
square root.
horizontal, right?
it means it's horizontal. Does anyone remember what A is? It's a horizontal shift. I'm literally going to write exactly the same thing I did yesterday. Plus would move it to the
Left.
plus would move to the left, and minus would move
Right.
right. Okay. How about B? Still inside the exponent, but now it's multiplication.
Horizontal stretch.
That's a horizontal stretch. Okay, as an example, if you had like 2 to the 3x, okay, that is a horizontal stretch, but it's backwards.
1/3.
That's a horizontal stretch by 1/3.
Yeah.
A bigger number makes it smaller.
Yeah.
Okay, so there's an example. Let's look at
Now.
2 to the 1/2x. That's still a horizontal
Would it be
stretch,
2?
but that's going to be by 2. Yep.
What if it was by like 4/5?
Horizontal stretch. No. Right. Horizontal stretch by factor of 2. So these are the only ones you have to remember. They're backwards. Okay. Plus is, you would think plus would be to the right, but it's not. Plus is left, minus is right. Okay.
Say you had like a number that was a 1 in the top. Does that change anything?
It's generally gonna have a 1 on the top.
Okay. So what? So would it?
Does it always have to in like real problems? No.
Okay.
In my problems, it will.
Okay.
So that's horizontal stretch. What does C do? It's on the outside,
Vertical stretch.
but it's like B because it's multiplication. Vertical stretch. And C is not backwards. If C is a 5, that's a vertical stretch by 5. If C is a half, that's a stretch by a half. What about D? It's on the outside.
Vertical shift.
That's your vertical shift.
Positive is up, negative is down.
And positive is up, negative is down. Yep. Now, last thing I'm going to add, what if B is negative, what does that cause your graph to do?
Reflect.
Reflect which way, horizontal or vertical?
Horizontal.
Horizontal, because it's in the box that does horizontal stuff. So horizontal reflection. What about if C is negative?
Want to be a vertical?
That's a vertical reflection. And a vertical reflection is over the x-axis. Yep.
Wait, if C is negative?
If C is negative, that would cause your graph, like if I just use like a letter to show you or a symbol, that's a vertical reflection. We do that. Horizontal reflection would look like this.
Yep.
And that's horizontal.
Wait, what did you say? Which way is positive and negative? Negative for the horizontal shift.
Okay, so now let's use that chart to describe a transformation.
Let's do it. We have the answers all written down.
Okay. So it says, list the transformations needed to change that into
Ooh.
that.
I don't know how to do that.
Okay, well, the first step is list how many transformations there are.
Wait, can we so can we just list the transformations that are in the second one, and then that's where you need to do the first?
Yeah.
Oh.
So how many transformations are in the one I circled in green?
4.
4. 3.
So we're looking at the numbers. So the 3 to the x and the 3 to the x are the same. That's
So
not
the
Right.
2, the plus 1, and the 5.
the 2, the plus 1, and the 5. So we have to describe what each one of those do.
So
Minus 5.
a vertical stretch up to.
So start with A, and then go to B, then C, then D. Is there a number in the A?
Horizontal
Yes.
Mhm.
to the left.
Horizontal shift. Left, how many?
1.
Yep. Left 1. Okay. Is there a number in the B?
Yeah. But
What
No.
number is in the B spot?
3.
No, 2.
No, 3 is your base.
Oh, wait.
That's your base.
No, there's
Oh.
No.
There's nothing.
B is the number that's in front of X. In this
Oh.
case, it's just a 1. So we skip B. Is there a number in the spot for C?
Yeah.
A
Right.
vertical stretch of 2.
So vertical stretch by factor of 2. While we're looking at it, let's look at B and C. Are there any negatives in B and C?
No.
No, so there's no reflections. Okay, so we don't have to worry about reflections.
So then would it be a vertical shift down 5?
Shift down 5. Yes. Yep. Those are all your transformations. So I would definitely, you don't need that chart for radicals and for the one we did today. It's the same chart. I would just make the chart so you have it for the test. Okay, so let me put up.
And then no homework because we're just so good.
We have 5.
Oh, what's that? What's that?
Oh.
Nothing.
She put that.
I protest.
Yeah, we're not going to do all of that.
Tomorrow. Oh, because we didn't.
This is all the problems between tonight and tomorrow.
Oh.
I see.
So for tonight, we're going to do
We're gonna do one of them.
Probably like half of them.
4 through 7. That's good.
What are you doing?
Wait.
What are you doing?
Get rid of.
This question scary today.
More things.
Yeah.
Okay, so that's the homework for tonight. The first part on 255, that's the radicals we finished up. And then 5.1 is the first part of exponentials. And we will finish exponentials tomorrow.
It's Friday, right?
No.
And test on
That's
Friday.
Friday.